I'm back with lesson 9.5D. In lesson 9.5D, we'll be talking about factoring trinomials for the purpose of solving and finding the roots or x-intercepts. Our essential question today is how to factor trinomials to solve to find the roots or x-intercepts. Now, whenever possible, when we are learning to do new skills in math, we want to make sure that we can connect our learning to a potential future task. So today we are going to add in how to solve for x. The first step of the process is to factor. Then we'll finish by solving, and we do this by setting each parenthesis equal to 0 and balancing to find the x-intercept or root. Let's go ahead and walk through the process. With the process, there's a couple things you should know. The first is that you always want to make sure that you have a polynomial or quadratic equation that is being set equal to 0. This is very important. Next, we want to go ahead and factor the left side. We are going to use our factoring skills we learned in the previous lessons. So to begin, there's no GCF, so we start by identifying A, B, and C. A is 1, B is 2, C is 3. Our magic questions are what adds to 2, negative 3 was C, and multiplies to equal negative 3. In this case, the only factors of 3 are 1 and 3. Because I want it to multiply to a negative, I know 1 must be positive and 1 must be negative. In this case, the 1 is negative. I'll place those values into the box. Remember, we attach an x to the magic question values. In the top left, I'll place x squared, and in the bottom right, I will place our negative 3. Factoring out what is in common, we get x and x. Negative 1 times x is negative 1x, and 3 times x is 3x. Notice the last box does check out. Negative 1 times 3 is negative 3. Now we have the new problem, x minus 1 times x plus 3 equals 0. I'm going to set each parenthesis equal to 0 to solve. This is called the zero product property. So x minus 1 equals 0, x plus 3 equals 0. Adding 1 to both sides gives me x equals 1. Subtracting 3 from both sides gives me x equals negative 3. I can state them as x equals values, or I can also write them as a coordinate point of 1, 0, or negative 3, 0. Pay attention to how it is asked. If it asks for an x-intercept, they're usually looking for a point. Let's take a look at a couple more examples. The first thing I notice in the next example is that it is set equal to 0. This is good. It needs to be set equal to 0 in order for this process to work. Next, we identify A is 1, B is 11, and C is 18. My magic questions become what add to 11 and multiply to 18. Listing my factors of 18, I have 1 and 18, 2 and 9, 3 and 6. Well, only one of those pairs will add to 11, so 2 and 9 it is. Placing those on the diagonals, and again, always attaching an x. Placing x squared in the top left and 18 in the bottom right. I'm now ready to do my factoring. X times x is x squared. X times 9 is 9x. X times 2 is 2x. Always be sure to check that they multiply out to equal 18 for the bottom last box. Now I write it in factored form, x plus 9 times x plus 2 equals 0. Next, we set each parenthesis equal to 0. Again, this is called the zero product property. It says that if two terms multiply to equal 0, one or both of those terms must also equal 0. From here, we balance, and we get x equals -9 and x equals -2. We can write it as those x equals values, or I can write them as a point. This time, I'm going to write them as the x equals because it just told me to solve for x. Let's move on to example B. First thing I always check, is it set equal to 0? In this case, it is. From here, we can go ahead and begin finding A, B, and C. Take a moment and do that. In this case, A is 1, B is -7, and C is 10. My magic questions become what adds to -7 and multiplies to 10? Well, listing out my factors of 10, I have 1 times 10 and 2 times 5. In this case, 2 and 5 are the only ones that could make a combination of -7. So I ask, can I make both negative and still have it multiply to a positive 10? I can, you're right. Let's go ahead and fill in our box. -2x, -5x. They always get the x attached because they are representing the middle term in our polynomial. X squared goes in the top left and 10 goes in the bottom right. Now it's time to factor and solve. So factoring out, I get x and x. X times -5 is -5x, and x times -2 is -2x. X minus 5 times x minus 2 equals 0. Now we use our zero product property to finish solving. Adding 5 to both sides gives me an answer of x equals 5 and x minus 2 equals 0. Adding 2 to both sides, x equals 2. All right, I have one last question for us to do. In example C, again, always starting, is it set equal to 0? Check. Now we can go ahead and factor. A equals 1, B equals 6, and C equals -16. Setting up our magic questions, what adds to 6 and multiplies to -16? I highly encourage you to write out your factors. It really does help. We have 1 times 16, 2 times 8, and 4 times 4. In this case, it is a -16, so one number will be positive and one number will be negative. So we'll use the factors 2 and 8. If I make the 2 negative, that makes it add to 6 and multiply to -16. I'll place those values into my sneaky square, attaching the x and then placing the remaining values from our starting quadratic in the remaining boxes. Now we can factor what is in common. So x times x is x squared, x times 8 is 8x, and x times -2 is -2x. Notice the last bottom corner box does check out. Now we have x plus 8 times x minus 2 equals 0. From here, we set each parenthesis equal to 0 and solve. Subtracting 8, x equals -8. Adding 2, x equals +2. From this lesson, I hope you realize that all of the quadratics is connected. Understanding how to factor helps us then figure out our x-intercepts, or where the graph crosses the x-axis. It's all connected, and when you can understand that connection, it makes it easier to work with the quadratics. Have a great day.